The first nation to build a permanent base on the moon doesn't just win a trophy, it seizes the gateway to the entire solar system. Every rocket, satellite, or Mars-bound ship must slingshot through the moon's gravity well, and whoever controls the refueling stations, communication relays, and construction hubs at that cosmic crossroads dictates the rules of space for centuries. In 1969, Neil Armstrong's bootprint on the Sea of Tranquility symbolized American technological supremacy and national pride, but that triumph faded into history more than half a century ago. Today, a new contender is accelerating with ruthless precision, investing billions and planning decades ahead. That contender is China. While NASA grapples with budget cuts and SpaceX battles explosive test flights, China's space agency, CNSA, is executing a master plan that could place Taikonauts on the lunar surface before anyone else returns. Welcome to Cosmic Frontier, the channel that decodes tomorrow, today. Buckle up because the lunar gold rush has already begun, and the finish line is 2030. China's lunar Odyssey did not begin with astronauts, it began with cold, hard data. In 2007, the Chang'e 1 orbiter circled the moon and produced the most detailed 3D map humanity had ever seen. 3 years later, Chang'e 2 refined those maps while practicing the orbital maneuvers that would guide future landings. These missions generated few headlines, yet they laid the foundation for everything to come. By 2013, Chang'e 3 achieved the first soft landing on the lunar surface since the Soviet Luna 24 in 1976. Its rover, U2, rolled across the basalt plains of Mare Imbrium, beaming back images and spectra that confirmed China had arrived as a serious spacefaring power. Western analysts dismissed these early steps as derivative, but the narrative shifted irreversibly in 2019. Chang'e 4 became the first spacecraft ever to touch down on the far side of the moon, the enigmatic hemisphere permanently hidden from Earth. Operating beyond line of sight required a dedicated relay satellite, QuickYo, positioned at the Earth-Moon L2 point. The mission was not merely symbolic, it demonstrated autonomous navigation, precision landing, and real-time data transmission across 380,000 kilometers of void. For decades, China had been labeled a copycat. With Chang'e 4, the copycat became the pioneer. These robotic triumphs were never ends in themselves, they were rehearsals for human footsteps. In 2020, Chang'e 5 launched aboard a Long March 5 rocket from Wenchang and executed the most complex lunar mission since Apollo 17. After touching down in Oceanus Procellarum, a robotic arm and drill collected 1.7 kilograms of fresh lunar regolith, material untouched by Earth's atmosphere for billions of years. A miniature ascent vehicle then blasted off the surface, rendezvoused with the orbiting return capsule, and delivered the samples to Inner Mongolia. For the first time in nearly half a century, brand new moon rocks sat in terrestrial laboratories, and they carried Chinese labels. In 2024, China raised the stakes to impossible. Chang'e 6 targeted the South Pole Aitken Basin on the far side of the moon, one of the oldest and deepest impact craters in the solar system. Over 53 days, an orbiter, lander, ascender, and return capsule performed an intricate choreography. The lander deployed a scoop and drill, gathered roughly 2 kilograms of ancient soil, and launched the samples into lunar orbit with a tiny rocket. Then came the maneuver no nation had ever attempted robotically: autonomous docking around the moon. A variable thrust 3,000 Newton engine guided the descent, laser-based LiDAR mapped hazards in real time, and a gamma-ray altimeter pierced dust clouds to ensure a perfect touchdown. Space analyst Andrew Jones notes that prototypes of crewed landers and capsules are already under construction, and CNSA officials have publicly committed to Taikonauts on lunar soil by 2030. Having mastered the far side, China now covets the most valuable real estate in the solar system, the Lunar South Pole. Permanently shadowed craters there harbor billions of tons of water ice, frozen since the birth of the solar system. A single ton of that ice can be split into oxygen for breathing, hydrogen for rocket fuel, and pure water for drinking. In 2026, Chang'e 7 will deploy a lander, orbiter, rover, and a miniature hopping probe designed to leap into craters too rugged for wheels. Ground-penetrating radar and a dedicated water analyzer will map subsurface ice and test extraction techniques. 2 years after, Chang'e 8 will push the envelope further. It will carry a 3D printer that melts lunar regolith into solid bricks and a 100-kilogram robot that stacks those bricks into habitable modules. This is in-situ resource utilization, ISRU in action, manufacturing with local materials instead of shipping everything from Earth at ruinous cost. Master ISRU, and a lunar base transitions from science outpost to self-sustaining colony.
By the end of this decade, the rehearsals end and the curtain rises. China plans to land its first Taikonauts on the Moon in 2029, deliberately scheduled for the 80th anniversary of the People's Republic. 3 technological pillars support the mission. First, the Long March 10, a 92-meter, 3-stage heavy-lift rocket capable of lofting 27 metric tons to lunar orbit. Powered by clusters of YF-100K kerosene engines, it rivals NASA's Space Launch System in performance, yet costs a fraction as much. A test flight is slated for 2027. Second, the Mengzhou Crew Capsule, a 26-ton next-generation spacecraft that carries 3 Taikonauts in deep space comfort. Larger and more modular than NASA's Orion, Mengzhou is optimized for repeated lunar sorties. Third, the Lanyue Lunar Lander, another 26-ton vehicle that ferries 2 astronauts to the surface while the third remains in orbit. Sleek, angular, and partially reusable, Lanyue inherits autonomous docking tech proven by Chang'e 5 and Chang'e 6. The mission architecture is elegant. One Long March 10 lofts Mengzhou into lunar orbit. A second launches Lanyue. The 2 craft rendezvous and dock robotically. Then 2 Taikonauts descend near Shackleton Crater, a sunlit ridge beside craters brimming with ice. They will spend 6 to 8 hours deploying instruments, collecting samples, and planting the 5-star red flag before returning to orbit. 6 hours may sound brief, but those hours will crown China as the second nation and the first in the 21st century to land humans on another world. Beijing is not investing tens of billions for a photo opportunity. The Moon's untapped resources are valued at $66 trillion. Rare earth metals for quantum computers, platinum group elements for catalysis, and helium-3 for clean fusion power, 1 ton of which could energize a city for a year. The blueprint for exploitation is the International Lunar Research Station, ILRS. Between 2031 and 2035, 5 robotic missions will deliver modular payloads. ILRS-1 establishes command, power, and communications. ILRS-2 deploys science labs. ILRS-3 builds fuel and oxygen plants from regolith. ILRS-4 networks robotic miners. ILRS-5 installs far-side telescopes free from Earth's radio noise. Originally a Sino-Russian partnership, the ILRS has expanded to include Pakistan, the United Arab Emirates, Turkey, Thailand, Iran, Peru, and others, an alternative bloc to NASA's Artemis Accords. By the mid-2030s, the ILRS could operate autonomously. By 2040, it could host rotating crews. By 2050, it could generate a lunar GDP. Picture 2035. Chinese modules gleam along Shackleton's rim, solar arrays drinking perpetual sunlight, robot arms stacking printed bricks into pressurized habitats. Cryogenic tanks store propellant distilled from crater ice. Orbiters relay high-bandwidth data to Beijing. Technologically, China will have mastered autonomous construction, cryogenic refueling, and industrial-scale cargo transfer via the Long March 9 Super Heavy rocket. Geopolitically, the South Pole becomes the solar system's first gas station. China sets the price per kilogram of propellant and the terms of access. Economically, lunar manufactured satellites and fusion fuel flood orbital markets, bypassing Earth's gravity and atmosphere. The United States is racing to catch up. NASA's Artemis 3 is officially targeted for 2026, but internal schedules point to 2028 to 2030. SpaceX's Starship can haul 150 tons to the moon, triple China's capacity, but explosions and regulatory delays persist. China's advantage is centralized planning immune to election cycles. America's is chaotic innovation and private sector agility. Two philosophies, one destination. The future need not be a new Cold War. Quiet talks explore resource-sharing treaties and unified lunar mining standards. Yet one truth is inescapable. The race is not about who arrives first, but who stays longest. When a single nation or coalition establishes a permanent foothold on that silver horizon, the balance of power on Earth tilts irreversibly. Private corporations complicate the board. Blue Origin, iSpace, and tomorrow's mega-corporations eye lunar real estate for profit, not prestige. That story deserves its own episode. So here is your call to action, Cosmic Frontier family. Who claims the next giant leap? China's disciplined machine? NASA's alliance of democracies? Or SpaceX's wildcard ambition? Drop your prediction in the comments and tag it #MoonRace2030. If this script rewired your view of the cosmos, smash the like button. Let us hit 10,000 likes together. Subscribe to Cosmic Frontier and tap the bell so you never miss a launch update. Next Thursday, we explore what happens when corporations colonize the moon. Profit, power, and the first lunar pizza delivery. This is Cosmic Frontier. We don't just report the future, we navigate it. See you on the lunar surface.